Question number 36 says, at maximum height for an oblique projectile, option 1 kinetic energy is 0, option 2 linear momentum is 0, option 3 kinetic energy is minimum but not 0, or option 4 linear momentum has the maximum magnitude. Dear student, as the projectile moves along its trajectory at the maximum height, the velocity of the projectile is in the horizontal direction and is equal to the initial velocity's horizontal component. That means that the vertical component of the velocity at the point when it is at maximum height is 0. Therefore, dear students, the speed of the projectile is minimum at the maximum height. And since the kinetic energy is simply half m into velocity magnitude square or half m into speed square, it means that the kinetic energy is also minimum. We must note that the speed of the projectile is not 0 at the maximum height, which means that the kinetic energy would not be 0, but it would be minimum. Therefore, dear students, the correct answer or the most appropriate answer for this particular question is actually option number 3. Now, dear students, let us proceed to the question number 37. Question number 37 says, for an observer on positive y-axis, a vector 3i cap is rotated by 90 degree anti-clockwise in xz plane. The new vector will be. Now, dear students, let us draw a diagram and try to visualize this particular question. If this is the x direction and we take the y direction as the direction coming out of the plane of the paper, then this direction would be the minus z direction. It is given initially that the vector is 3i cap, which means that the vector is aligned along x-axis and the vector has a magnitude 3, precisely 3i cap vector. Now, for an observer at positive y-axis, it is observed that the vector is rotated anti-clockwise by an angle of 90 degree, which means that this particular vector would finally be aligned along negative z direction. Please note that the magnitude of the vector would remain unchanged. This means that the final vector can be represented as 3 minus k cap, because minus k cap would represent the direction along minus z axis. And hence, dear students, the correct answer for this particular question is option number 4. Now let us proceed to the question number 38. Question number 38 says, a particle is projected from ground with speed 20 meters per second. If the horizontal range of projectile is 20 meters, then the angle of projection is. Now, dear students, the angle of projection can be calculated using the formula u square sine 2 theta divided by g. Here u is the initial speed of projection and theta is the angle of projection. It is given that this is equal to 20 meters. Also, dear students, as per the question, u is equal to 20 meter per second. Substituting the given values, we can write that 20 is equal to 20 square sine 2 theta by g, which is 10, which means that sine 2 theta is equal to half. Or, dear students, 2 theta is equal to 30 degrees and theta is equal to 30 by 2, that will be 15 degrees. Dear students, this is the angle measured from horizontal. With respect to vertical, the angle can be said to be equal to 90 minus 15, which will be 75 degrees. This angle will be with the vertical. So, dear students, the angle of projection is 75 degree with the vertical or 15 degree with the horizontal. So, the correct answer for this particular question is option number 2, which says 75 degrees with the vertical. Now, let us proceed to the next question, which is question number 39. Question number 39 says, from top of a tower of height 100 meters, two particles A and B are simultaneously projected in horizontal direction with speeds 20 meters per second and 40 meters per second respectively. The time taken to reach the ground will be. Now, dear students, it is given that the height of the tower is 100 meters. and two particles are projected from top of the tower with 20 meter per second speed and 40 meter per second speed. The initial velocities of projections for both the particles is in horizontal direction. Dear students, this means that for both the particles, the initial velocity has no vertical component. Also, since the acceleration due to gravity is same for both the particles, the time taken in this case, which would be equal to under root of 2h by g, where h is the height of the tower and g is the acceleration due to gravity, it would be same for both the particles. And hence, the correct answer for this question is option number 3. Dear students, let us proceed to question number 40. Question number 40 says the equation of trajectory of a projectile is y is equal to bx minus ax square. Symbols have their usual meanings and a and b are positive constants. The angle of projection from the horizontal for the projectile is. Now dear students, for a projectile we can write that y is equal to x tan theta 1 minus x by r, where r is the range and theta is the angle of projection. This can be further simplified and be written as x tan theta minus x square tan theta by r. Dear students, if we compare this equation with the equation given in the question, that is y is equal to bx minus ax square, we can easily see that tan theta is analogous to b or equal to b, which means that theta is equal to tan inverse b. Therefore, dear students, the correct answer for this question, which asks us to calculate the angle of projection, is option number 1. Now let us proceed to the question number 41.